Hi, in today's video, I'm going to talk about Diffie-Hellman key exchange. So before I get into that, I'm going to create a hypothetical scenario to seed your thought process. So suppose you and your friend are standing in a room and you both need to agree upon a number, say 15, okay? But whatever number you pick, you both need to be on the same number. But the problem is there's a spy standing there and he's listening to all your conversation and you cannot let him know what is that number. So is there a way? So you both are talking, whatever you talk, the spy is listening. So is there a way for both of you to agree on a number that the spy does not know? And that is Diffie-Hellman key exchange. So this gives you a way. The way it works in a nutshell is you will think of a number in your head, your private key. So you will think of a number in your head which you don't tell anybody, and that's why it's called a private key. Your friend will think a number in his head and he'll also not tell anybody. And what you do is using these formulas which are publicly available, which the spy is also able to see. There are these formulas written on the board. The spy is able to see the same formula you and your friend are seeing. You take your private number, use this formula to generate a public key, and you tell that public key out to your friend. And your friend will do the same thing. He'll keep the secret in his head, use these formulas, which using the secret key. So see, this is the private key, which is the secret. He will use these formulas to generate a public key to tell you. So you both exchange public key, which the spy is listening to. Then what you do, you take the public key and then again run through this formula for the symmetric key, where you also need your private key, again, which is only in your head. The spy doesn't know. So you take that public key your friend told you, your private key, do this formula and keep that answer in your head. You don't say it out. Your friend will do the same thing. He will take your public key. He'll take your public key, which the spy heard, his private key, which only he knows. You also don't know, the spy also doesn't know, only he knows. Takes that private key, runs through this formula, comes up with a number, and the number you both come up with will be exactly the same number. So let's see an example. So the way this works is you take some large prime number. So for the sake of the example, I took 13, but in a real life, it will be a very large number in real life. So you take a large prime number, then you get a primitive root modulo of that number. So I'm not going to get into how you get the primitive root modulo. There are online calculators where you put in a prime number and it will give you all the primitive root modulos, which is also publicly available information. So which the spy will also know, which is fine. So you take the number, and so these are the primitive root modulos of this number. You pick any one of these. So I picked 7. So that 7 is your G. Prime number 13, one of the primitive root modulos G, and that's all. This only numbers that plug in here. Then what happens? Let's come to you and your friend. So you have a private key. What you do, you have to use this formula to generate a public key. So the way you generate public key is G raised to your private key modulo P, which is 7 raised to private based on the numbers we chose. It's going to be 7 raised to your private key modulo 13. So if you picked 4, your public key would be 7 raised to 4 modulo 13, which comes up to 9. Similarly, your friend also picks a private key 3, which is again only in his head. He is not telling anyone about it. He takes his private key, 7 raised to private modulo 13, which is 7 raised to 3 modulo 13, comes out to 5. He will tell you 5, you will tell him 9. And now you come to the part of the symmetric key. What you do is you take your friend's public key raised to your private key modulo P. So your friend's public key is 5 raised to your private key, which only you know, mod 13 equal to 1, and then the other way around the same thing. Your friend takes your public key, which the spy also heard, raised to 3, which only you know, modulo 13 1. So only people who know either this private key or this private key can come up with this symmetric key. Now you might think, what if the spy generates his own private and public key? He can generate his own private and public key. So for example, suppose the spy picked his own private key of 2. So based on this formula, his public key will come out to be 10. And if he takes 5 and runs through this formula, his symmetric key is going to come out to be 12, not 1. Now you might think, what if I was working with the spy? He'll come up with 12, I'll come up with 1. No, you will not come up with 1, because if you are working with the spy, you will use his public key instead of this guy's public key, in which case you will also have symmetric key 12. So that's Diffie-Hellman key exchange in a summary. Thank you.